toutes et à tous.
Well, good afternoon. We are very happy to welcome you with Emmanuel within this workshop. And today we are going to talk about shadow tea. And Manuel, well, she will show you at the end. And she is an expert in cybersecurity. And I'm myself an auditor and a cybersecurity specialist. So don't hesitate to come closer, and the screens are rather small. So there will be some slides, and it's not really easy to see otherwise. So to have a view on the screen. What are we going to do? Theory first, what is shadow tea and where can you find shadow tea? What's the vulnerability? What risk for that job as shadow tea? And we'll end with a case. What happens in a power plant when the shadow tea is being attacked? So this is a simulation with Airbus on the cyber range, and you will see it is quite impressive. I'll leave you a few minutes for the last commas. What is shadow tea? Shadow IT is something you know, I think, and we have been talking for years about that. It's the idea that you are in the IT network with some unidentified elements and the company doesn't master, doesn't control on. We used to have ADSL boxes and switches in the offices, and when you connected that, you get loops, and that was quite a long time ago. We didn't know where it came from, but we all get used to shadow IT. And with the IT in this tool, we have to face the same kind of behavior. So you got everything we know. You got PCs, personal computers, the interfaces, but also the historians, SCADA, the captors, everything, the catches, everything is present. No real issue, but there is already an issue with what we know. It's hard to make it secure and safe. Some unidentified objects, and you can find all kinds of things. Also ADSL boxes, just for a need, for a certain job, no connection. You put a 4G connection. Also old systems, we lost the use of people who retired or changed company, and they left the system without any documents. We don't know it is connected, for instance, some objects, a former system which has not been reviewed but is remaining connected. So it's all this shadow IT, shadow T. And it is something you can see quite often, I'd say. So take a microphone, please. I don't know if you have ever been faced with this kind of tools. So this is a poll. Did you ever experience shadow tea? Maybe you are not even informed about that. So you better have a look at that, because there are certainly some. In practice, and I show a network scheme on the screen. You've got the tools network on the upper side and the IT at the latter side, the classical network and the IT network with RP, historians, the different posts, potentially, I mean, the computers, the SCADA, some automats, but also, of course, cellular phones. They're all connected to the 5G, isn't it? And sensors or ERP, and some remote operators working on tele maintenance and cloud SCADA, all the Industry 4.0 that can be steered from the cloud on. So it is a former SCADA which is still connected. Of course, that's something you can experience. It's not anymore used, but it's there with access to the cloud without control. Components, tool components that have been provide some information to the cloud to inform the producer or to proceed to prevention maintenance. So you have got not a grip on that. There's a lot of subcontracting in the tools for maintenance, but also subcontracting. You got a position without authentication of the person, and whosoever can get connected. That's an unsecured subcontractor. As from the point of view of the staff, from the people, it is unknown, it is unidentified. So you can also get a link, and it happens. We connect and automate on the IT, on the OT, because you need a direct straight IP connection. So it's a shortcut on the switch. And so you can see all kinds of also Wi-Fi cards which are on the road on equipment you recently installed. You don't know there's Bluetooth, you don't know there's 4G, and it does exist. But also the IoT sensors. And this is something you can find. The Shadow T is to be found on a industrial system, and the ADSL box, and that's also quite successful, quite widespread. And this is an example, a producer of a food analysis. It is to analyze nitrates to be compliant with the rules of food rules. So it's a major producer, and he is all over the world, widespread, has to face a lot of standards, has to comply with. It's a case that we experienced in our job. It's quite imposing. In one dedicated room, you might think it is safe. This is connected to the OT room, to the ERP, in order to feedback the analysis results. There is no problem until here. It is to be secured, of course. We know where it is. But the producer, well, it's quite expensive. It needs some predictive prevention maintenance, and it'd like to provide the service. Hence, and this has been revealed in an audit, there used to be a 4G modem within that equipment, a modem with a 4G card. And the prevention maintenance has been done via the 4G card. It's not an issue to do that. If it's well done, there's no problem. But the issue, we are not informed. It's not identified. And the job, the RSSI, is not informed about the risk. And potentially you have to face a certain vulnerability as regards the 4G. This does exist. And vulnerabilities, well, you got the classical of a non-managed equipment. You get weak passwords which is not managed because the equipment is not identified. So the word password by default, which is never changed, and that has become a very simple entrance. We'll get also the absence of patches. It's not up to date anymore, and the system is getting older, vulnerabilities, and no update. We get absence of a filtering policy. It is connected, we don't know where. Potentially, there is an access to the whole network, to what it is connected. Data is not ciphered. You might, or encrypted. There might be an issue of secrecy, of confidentiality, and also the patent, if there is some trusted data on that. Systems are not strengthened, of course, not hardened. And interesting, there's no management of availability on that shadow IT because it's unidentified, no risk analysis. And it might happen that this shadow IT be needed to have the production chain working. If it's there, usually it is because it's necessary. Shadow IT, it is admissible. People will introduce that app without warning ADSI because there's a need and it is creating business and it is a solution. But it's unmanaged. If it was to be falling, Shadow T will fail and put into jeopardize the whole set of the job. And of course, one has to deal with unqualified stuff. So it's not compliant and has not been checked whether it is compliant to the safety measures. There's another real case of shadow IT. It's in a casino. Somebody has already heard that information, that piece of information. And on this picture, it's a casino with the money machines behind. There's a fire detection system, and in this case, it's known, it is managed, and there's no problem. You will see later on, we are going to use the fire detection system to get into the system. And you get also a classical tele-connected system. It was to be managed. And the money machines are also connected, very efficient. In a casino, this has been used. And the camera management, video, and tele control. This is a casino, and it manages its safety, but it will be hacked, this casino. How will this happen, according to you? How do the hackers get into that system? The aquarium? The aquarium. Yes, indeed, because you can see it on the picture. But here, there is a thermometer, and there is a water management system. And it is that system which has not been covered. There was a wireless interface were connected to the internet, but also related to the IT. And this was the opening to the casino. It was in 2018. It's only 3 years ago. And the shadow IT, be careful, that is dangerous. And the other danger, if it is not managed, there is no management of access, no IAM, no management of departure. The person introducing that, when it's leaving, it still has access to Shadow T. It will leave that person with the codes. Hence, you get a management issue. There's also, of course, a violation. You're on 7001 standards, and there's IOC food standards which have to be abided by. So you will, of course, infringe that standard. Insurance contracts, and we talked about that with the ransomware, and they have to contribute. There will be an increase of the insurance price. This is a case of exclusion. If it's not declared into the contract, if there's an inventory issue, a safety issue, you will not be covered by your cyber insurance. So the cost is not to be neglected. And contractual responsibilities of your customers. If you are a subcontractor, you have got safety standards to abide by. If you get a system with Shadow IT, you won't abide by this request. So potentially, you might be sued and you have to pay. So this is a really heavy one. And the last one, it is the infringement. It's GRPD, and you didn't do that work correctly, then you can get sued. So that is important, court to court. Make that inventory. and a few good practices. How to deal with that in order to try to prevent from shadow T. This is a technical issue. We are suggested technical solutions, but there is also some good practices, and that will be quite obvious, just to be repeated. Some technical measures, and I took that scheme of a while ago, and the very first measure, technical decision, is segmentation. Segmentation of the OT network, which is not only important for the shadow IT, but also generally of your whole tool. So it's about to devise, to segment. It's not about filtering or enhanced filters. No, just to know this has to go there, and you just put the equipment and some simple rules. You need to proceed step by step. It will not be saved, secured to one day to the other, but it's a method of small steps. Doing this, you will avoid a former system to be connected and sensors from the ADSL to get connected. They will be identified, and if they are not undeclared, they have no right to get connected. And that's the basis, to segment. Departmentalization, IT, to control the flow of exchange in between cloud of a RP and the RT. The second, it is advanced filtering of IT and OT and authentication. You will see that in the case. To authenticate into the safety system, the operators that attempt to get into the system and that want to dialogue. That can be done at a low level of the filtering system without getting to the bastion, which is the ultimate solution. And as such, you have proceeded to a very first step. Emmanuel will show you in a presentation next to this presentation. For such an operator to get access to the maintenance, well, I'm managing the authentication, and as such, I reduced the risk. Third, you can log. It's very good to log in, and once you logged in, you can put all login in a collector, and you can work on a mapping or a knowledge of that flow, the flows. To map, it's good. Look, where are my flows? What's happening? And to start to have an idea of who is communicating with what. That's what you can do after segmentation, and you can work on more fine-tuned filtering techniques. Decisions at the start, you get it's a general flow scheme. And then the inspection, the deep inspection of the flow, IPS deep inspection. And in that case, you can get into the network, the command area. You know that the thermometer needs to be between 10 and 50 degrees, otherwise it's an error. Let's take a fork of 200 degrees, it's thrown away. This command, and you get orders for 100 tools. If you get an order of 500, it's false, it's an error. This is what you can do with protocol analysis without talking about signature. You can detect attacks on a vulnerability of the tool. Every day we can find some specific signatures, and it is into that system you get the whole package. And it is being analyzed. Now you get a demonstration. This is the technical aspect. Well, the goal, it's also to abide by the standards 40443 in order to organize the whole segmentation. Thank you. There's also the C43.
Yes, sir.
62443, apparently it's a bit of a
It's a bit of a difficult one to remember. So regarding organizational measures, so best practices are available from ISO 27001. So on-site audits are very efficient as well for several reasons. So to detect shadow OT, we notice that very often physically. You can see a cable, you could see, stuff that is not where it should be. But beyond that, it's also possible to have a proper exchange, to have a conversation, to find out, automaticians, people who are in charge, and to go have a chat with them to help them understand what's at stake for cybersecurity today or in cybersecurity today. So when I say audit, I don't mean you should go there and tell them I'm an auditor and I'm going to teach you how to live. It's about listening to people. It's about discussion, I suppose. And that makes it possible for you also to have some feedback. Maybe that person will tell you, oh yeah, but I have that problem, so this is how we ended up with that situation. And they will give you information. They do their best for the company, and so do you. So I think it's more important to remember that we're all in the same boat, and the idea for us is not to start again giving big lectures or explaining to people how and why they should do things. It's all about having a conversation. It's also important to have a look at the logs, to have a look at the IPs on the networks. Raising awareness, training people is very important too. You have to communicate regarding what's at stake. You have to communicate about what the impacts may be when you tell an automator that you're here to avoid that there is any safety impact. You understand one another. This is really what matters. This is what it's all about. Regarding safety for subcontractors, that's very important. Do not forget security demands. This is why we do that. We need to think about that at the very beginning. At the very beginning, we think that we need an operator to authentify the employees, to check everything. So it's good to have the right basis, to have a healthy basis in terms of standards. We spoke about it yesterday in Roundtable. A lot of service providers are not up to specs. You might have higher levels of demand, but when you get an answer, you know that out of the 30 demands that you had, that service provider can satisfy 5, and you can tell them, yes, but you need to make an effort, and this one and that one are a no-go. I need to have that solution, and for the rest you can find some solutions. Sometimes it costs money, and then you have to have that conversation with the service provider in order to maybe decrease the prices. So it's important to have all that on paper, but it's even better actually to check that what is said is actually done. What is promised is actually delivered. It's very important for those of you who know GDPR. You know that in GDPR you are still responsible for data management, even though you work with subcontractors. When you're managing data management, when you're responsible, you need to make sure that the subcontractor does what they said they'd do. And it's the same here. You need to check on site that what was promised is indeed applied. So this is for organizational questions. Let's move on to the demonstration. Do you actually have any questions regarding the theory of it? Any remarks, comments, anything? If that is not the case, then Manu, I'll leave the floor to you for the demonstration. Perfect. So here we have a graphic representation of a substation, an electric substation. So it's a very simplified schematics of an electric substation. So this is what feeds into the electric networks, the grid. So we have defined the theme for the production, for energy production and electricity production. Some of the demonstrations is done by us, or some of it is done by other stakeholders. This electric substation is made up of 3 levels. Level 0, which will communicate with level 1 via protocol SV, is what we call it. This protocol is not understandable by IEDs. IEDs are PLCs, they're automaton devices that are dedicated to the world of energy. Protocol SV will go through a merging station. A merging station will communicate with the IEDs, which will potentially be able to activate some elements in the electrical grid, so circuit breakers, voltage transformers, and so on and so forth. So all of those elements will then communicate with one another via a protocol called Booz protocol. So that will synchronize all the different devices in order to have the same volt level throughout the grid. For example, IDs are connected then to level 2, which has to do with supervising the SCADA part. So it's going to supervise, orchestrate, so to speak, everything. All of that is also standardized, not with the 62443. Yeah, I'm sure I'll hear, this is not the last I've heard of 62443, right? No, it's actually IEC 61850. This is another standard. It's an electric standard. It's not just a standard. It's also a set of protocols that are presented here, SV, Booz, and MMS. We can move on to the next slide, please. So here we have our this is the playing field, I guess, for the future. So we have, at the core of it, you have a substation, which is very streamlined. So here you can just see the Goose part and the MMS part. The SV part is outside of the scope of our demonstration because Goose and MMS are the easiest to explain. So this demonstration focuses on, so as Sebastian said before, it's really focused on a maintenance workstation right here that will teleoperate or operate remotely and maintain a sensor. So that's a firefighting workstation. It will be connected via a legitimate network, via a firewall that will not have an IPS. This is just focusing on source and destination IP, and that will then be connected to the sensors. So those sensors, sadly, as Sebastian explained, have been connected to the substation network by a maintenance team. Maybe they forgot to unplug a cable, let's say. So an attacker will take control of the maintenance workstation, will use the legitimate communications and will go downstream, rescan the network, and notice that on the substation network you can connect to the sensors. And here you have it. So basically they can attack the substation networks. So the demonstration will be focused today on two different things. First of all, so one part will be IPS free, and another part will be with IPS and authentication. So in the first part, for the first part of each of those two parts, we'll have a first Goose attack, so it will attack the publisher and subscriber Goose, and then you want to desynchronize the network entirely. So that will make the network safe and trigger a shutdown of some of the city. The second part is the MMS aspect. So here the attacker has positioned themselves on the MMS, in the MMS part, and will try to enter illegitimate commands on the MMS server, which will try to securize itself again and trigger the shutdown. So I wanted to show you the attack demonstration live, but we don't really have a PC connection actually. So we are going to show you that via a video. If you want to see it live, come to the Storm Shield booth and we will show you that. Let's have a look at the video for now. If it works, that is. Not this one. And also not that one. This is not the one?
Non. Changez la vidéo, vous êtes sur la deuxième partie.
Also not this one. This is part 2 with the IPS. Let's start with the first IPS free phase, please.
Bon, en attendant, je peux vous...
In the meantime, I can at least explain some of the context. So we are using a platform, so an Airbus cybersecurity platform. This is a cyber range, for those of you who know it. So it's a platform that makes it possible to virtualize and to do some digital twins, to carry out some tests, trainings, online trainings, especially during COVID. We were able to test things out on this platform. So there we go. There we have it. It's a super quick video. So I think this is like, yeah, this is super quick. Can we maybe slow it down a little? This is way fast, sorry. I can't possibly explain anything that fast. Okay, so let me continue actually with the presentation, so with the environment. So this environment makes it possible to create demonstrations. So we have trainings, pre-sales. We can also demonstrate some solutions to the clients. We can also try to narrow down what the client actually needs. I'm going to try and make it as is. So here I've opened a window, which is right here. This is the Goose subscriber, which will make it possible to have, you know, the tension, the frequency, and the intensity broadcast, as well as the sequence number for synchronization between several elements, a Goose publisher and Goose subscriber. We have a vision for the city as well, so bird's eye view of the city, a view of the plant as well. Our attacker is positioned, is just waiting for the right moment to attack. They're positioned in this area at the level of the sensors, and the attacker will launch a first attack, a Goose attack, which will desynchronize the communications, and we will see in a second what is going to happen following this. You can maybe press play for a second. Can you? It's the demo effect, isn't it? This just never can work when we need it to. So the PC is 25 FPS, but we've recorded the screens 8 FPS, so that's 4 times faster than we thought it would be. They are putting it back on the PC, and I think we should be okay. Are we okay? It looks a little better, doesn't it? It looks a lot better, except it doesn't actually. So let's continue. So on the cyber range that you'll see in a second, we have a cloud version and a physical version, and that's it. What I can tell you also regarding, so at Storm Shield, we have a new product called SNI20 that responds to constraints specifically for the energy sector. So it's SNI20. So it corresponds to standard 61850. So it makes it possible to protect the electric equipment. It's a very hostile environment. So this is a firewall that is so IP30. It's got a bypass mode, which will make it possible, if there's a problem with the firewall, to continue to guarantee proper functioning of the facility, nominal operation. Often I speak of dams, water dams, you know, like if you have a command station and an automaton that pilots the doors of the dam, you always have to be able to close the doors to shut down the dam. Otherwise you can have floodings in the valley. It can be a huge catastrophe. So we need to have the right firewall, and if the firewall fails, you need to still have a mechanical solution for that to close down the doors. So through that bypass mode, with the SNI40, SNI20, we will manage to guarantee this double protection, I guess, if you want to call it. It's nonsense from an IT perspective, but when human lives are at stake, when we're talking about a dam, a hydraulic dam, it makes perfect sense. So this is part of the functionalities in terms of safety of operations that we really wanted to have in place and available. The industrial protocols that we've integrated to the firewall, I mean, I'm trying to... The industrial protocols that we've integrated in the firewalls are 213. The latest is 61850. We have Profil A, Profilas. For water, for the water industry, we've integrated for the next versions some dedicated protocols for the supervision of water, so with Software. And this is really for the purely water-based industries, so water towers, all of that. We have a couple of companies managing that in France that we're working with. It is not working. I do not know why, but it is just simply refusing to work today, that video. So what shall we do? Shall I just put it on my PC and you can join me in the back? Yeah, it looks like the video projection just is completely... Everything went awry. I'm really sorry about that. So, yeah. Anywho, you can come to booth S15 where it works perfectly. We have 2 screens. And we have beer. Another noteworthy information is we have beer as well as coffee. So otherwise you can just show us the accelerated version. Anyways, we don't have time anymore. So do you have any questions though regarding the demonstration that we have failed to show you? Don't hesitate though, like if you have anything, like if you have had cases of shadow OT, if you have questions regarding how to manage all that, the demonstration was actually fun. You could see everything shutting down and the city in blackout and all that. It's always kind of fun to imagine such catastrophic scenarios. It's not like we have pandemics every day, is it? So anyways, you please show up, come see us on the booth. Yeah, the aim of the demonstration was also to show you the ability of protection of Storm Shield and the ability to block some commands for, towards the devices. We have plugins available to do that, plugins that are created based on studying the protocols. It's not just about signature, it's about plugin again. So it's about having a look at the protocol specifically. We'll know the dictionary of the protocol, so RFC. We will know the grammar of that protocol. We'll know how it interacts with the ecosystem, and therefore it's really because of that, based on that, that we will create this is our main strength at Storm Shield, and it gives us a good ability to detect problems while having, as you imagine, a standard sheet of paper. If you make holes in it, what we do is we look for values 0, 1, 0, 1, 0, 1, and then you can detect the values you're looking for through the hole, basically, if you have a model behind it. And if you remove the sheet, you will detect the protocol where you were looking for it, but you could also detect it somewhere else on the pattern, and it can generate false positives. So our solution aims at preventing such false positive situations. It guarantees... Yes? Is there a question? I think we've broken the microphone as well. How do you manage things in real time? Well, we can't. We're getting closer to in real time, but also how do you define in real time? There's always some degree of delay. I mean, there's no such thing as real time. What do you mean? Is it a microsecond, a nanosecond? It all depends on your definition of it. We can go down to 10 milliseconds. So the definition of in real time is a bit of a question mark, or is a bit of a debate in and of itself. Thank you very much. So yeah, this is our philosophy. We try to guarantee that we may activate the IPS. When you see in a lot of industrial networks is that they have firewalls, industrial firewalls, but no IPS, and then you can't detect there are a lot of things that you can't detect with such a firewall. Our added value is we come from the world of IT, and we can give you, you know, those detection abilities to the OT world. So we didn't start from scratch either. We created a partnership with Schneider. They came and helped us out with the OT aspects, and we worked on the IT aspects. So we have managed to have SNI 40, which was the very first product in the history of Storm Shield, dedicated to the world of industry. So we still don't have the video, do we? Is it? I can see you're sweating. No? No chance? Tough luck. Well, this will be a day to remember. I'm sure you'll remember it as well. Our great demonstration. It is a pity. Thank you so much for sticking around, though, and thank you very much for coming as well. And do come to see us in the booth. And we have 2 booths actually, and we can show you the demonstration on both. So the CFI by Sophic, and on the main Storm Shield booth as well. Thank you very much, and I'll